Hello and welcome to our review of 9.1 through 9.3. Hope you feel that you can identify a quadratic function from an equation, table, and graph, determine the direction the graph opens, whether upward or downward, determine whether the vertex contains the min or the max, that you can find the domain and range, find the zeros and axis of symmetry from a graph, and then find the axis of symmetry and vertex from an equation. So if we get started here, we look at information about functions or relations technically, I guess. And when you look at the tables, we want to find the second difference. First we verify that the x changes by a constant amount. And then if I do negative 1 plus 4, because minus a negative, I get a 3, 2 plus 1, 5 minus 2, 8 minus 5. This has a constant first difference. We're looking for a constant second difference. So this one is not quadratic. It's linear, technically. Take a look over here. Again, verify the x. Now if I do 8 minus 4, I get 4. 16 minus 8, 8. 32 minus 16, 64 minus 32. And when I do these differences, 4, 8, 16. The second difference is not constant either, so this one's not quadratic. It looks like an exponential. If I change or look for the change in x's over here, I get a constant. Over here I get 5 minus 0, 12 minus 5, 21 minus 12, 32 minus 21, that's 11. And then the second difference, sure enough, change of 2. So this one is quadratic. In these equations, if we take a look at these, we look for an x squared. Here I have 2x plus 2x. Those are like terms, but they're not x to the 2. So this one is not quadratic. 8 to the x. I'm looking for the variable to be raised to the 2, and this is a constant raised to an x. That one's not. And then finally this one is quadratic. I look through the graphs here. The shape is supposed to look like a U or an upside down U, and this has a little more stuff going on. This one's not quadratic. This one is not even a function because it doesn't pass the vertical line test. It's not quadratic either. Now we look at the graph here. This is what a parabola would look like. The representation on the right is a graph. It's not an equation, words, or a table. And so we want to know, and it's fairly obvious, we want to know whether or not this thing opens up or down. It opens downward. It has zeros on the x-axis here of negative 1 and positive 2. To find the axis of symmetry, we find the middle of these two values, the zeros. So we just get their average. It would be nice if it was right on what we call a lattice point, one of these intersections, but we can find the value of x by simply doing negative 1 plus 2 over 2, and that's 1/2. Makes sense. It looks like it's between 0 and 1. And then to find the vertex, fortunately it does look like it reaches this line right here for y, 1, 2, 3, 4, and that's a 5. That causes us, because it opens down, it causes us to see that the maximum value of the function, it's the y value, is 5, and the domain, as we have for all quadratics, is going to be all real values. And then the range, if it opens down, it's less than. If it opens up, if a parabola opened up, it'd be greater than. So in this case, less than or equal to the k 5. Okay, let's try this one. Why don't you try it first, hit pause, and then when you need help or to verify, just hit play. Okay, it's fairly obvious. This thing opens up or upward. Zeros are going to be at these x-intercepts, negative 1, 1, 2, 3, 4, 5. Has an axis of symmetry, the average, negative 1 plus 5 divided by 2. That's 4 over 2 or 2. And that seems reasonable. We place our axis of symmetry here. And then the y-coordinate, 1, 2, 3, 4, negative 5. So 2, negative 5 is our vertex. It opens up, making it a minimum. The value of y starts up at positive infinity from left to right, comes down to negative 5, turns around and goes back up. So the the minimum is negative 5. Domain again, all reals. The y gets to negative 5, starts at negative 5, we could say, and goes all the way up as far as a range. So it's greater than or equal to negative 5. Representation here is an equation. Let's go through this one. Because the a, the leading coefficient, is negative, we know this thing will open downward. The zeros, a little bit tougher to find. We're not going to be able to get those from the equation just yet. We can do some work with that in later sections. Has an axis of symmetry. The way we find that is x equals negative b over 2a. So if we plug in negative 8 over 2 times negative 2, we get negative 8 over negative 4. That's a positive 2. So we would say axis of symmetry is x equals 2. Gives us an x-coordinate for the vertex of 2. We plug in 2 up here. We get negative 2 times 2 squared plus 8 times 2 plus 1. That'll give us 2 squared is 4, so negative 8 plus 16 plus 1. If we do the math on that, we get 9. So the vertex is 2, 9. Because it opens downward, it's going to have a shape like an upside down U. We're going to have a maximum up here at the top for y. So it's a maximum of 9. Again, the domain, all reals. And since it's a max, it'll get up to 9 and then come down from there. So no bigger than 9 or less or equal to 9. Why don't you give this one a try, following the same process. And remember, we're not going to be able to find the zeros just yet. Then you can hit play to see how your work compares. All right, the a, kind of hard to see here, is a positive 1. So since it's positive, our parabola will open up. The axis of symmetry comes from negative b, so negative negative 6, over 2 times 1. It gives us 6 over 2, or 3. That then is our h for our vertex. We find our k by plugging in the 3. We get, I'll do the math in my head here, 9 minus 18 plus 7. So 9 minus 18 is negative 9, plus 7 is negative 2. Because this parabola looks like a U, it's going to have a minimum down at the bottom. And that value is negative 2 for y. Domain and the range greater than or equal to negative 2. Okay, our last problem is going to be one of the graphing ones. Fair amount of work to do here. Go ahead and try it. Remember the previous video went through this material. Go ahead and hit pause and hit play to check your work. All right, to start with, we're going to have to get the y by itself, which means to add the 2x over. So if we ultimately end up with standard form, we get something like this. To find the axis of symmetry, we're going to do negative 8 over 2 times 2, and that's going to be negative 8 over 4, which is negative 2. So our axis of symmetry is x equals negative 2. That makes our h of our vertex negative 2. And then our k is going to come from plugging in our x here. So in this case, plugging in negative 2 gives us a 2 times negative 2 squared plus 8 times negative 2 plus 3. And that is 4 times 2, 8 minus 16 plus 3. So negative 8 plus 3 is negative 5. Well, we've got our little axis of symmetry here. We'll go over to negative 2, and we can throw that out here. Goes forever. To do h plus 1, we take our h of negative 1, add 1, we get negative 1, and plug that in. So I'm going to need a little bit of space here to do my work. 2 times negative 1 squared plus 8 times negative 1 plus 3. That gives us 2 minus 8 plus 3, which is negative 3. I'll go ahead and start plotting these points. Negative 2, 1, 2. Here's our vertex. Right on the axis of symmetry makes sense. Negative 1, negative 3. Point 2 is going to be adding 1 to our vertex, or adding 2, I'm sorry. So negative 2 plus 2, 0. Plug in 0, that becomes easy. We'll just get 3. So 0, 1, 2, 3. Okay. And now what we want to do is have a quick look at our axis here and reflect over these dots. And we get a shape like this. The negative 1, if we go negative 2 minus 1 instead of adding 1, we would end up with negative 3 and the negative 3. We subtracted 2, we'd get negative 4 and the 3. And sure enough, if you look here, 1, 2, 3 at negative 3, we're at negative 3, and at negative 4, we're at positive 3. This is our shape, roughly something like this. All right. We didn't predict ahead of time, but if we check here, because A was positive, it opened up. Parabola did. The max or min, in this case, since it opened us up, we're going to have a minimum down at the K or the Y coordinate of the vertex, negative 5. The domain, again, all reals, and since it's a minimum, the range is Y greater than or equal to the K, in this case, negative 5. Hope you feel ready for the test. Come prepared with questions if you have them, and we'll see you in class.